Hello, we're going to go through today the answers to the questions that I set for homework about moments. So the model answer question, the 1.2 Newton ball has a turning effect on the arm. Calculate the moment of the 1.2 Newton ball. Well, the first thing is always to write down the equation for moment, which you'll recognise as moment equals force times perpendicular distance from the pivot. So we've got the pivot just here. So if we're trying to calculate the moment caused by the 1.2 Newton ball, then we know the force is 1.2 newtons and the distance from the pivot is this one, which is 0.2. So let's now look at how we would write it out in this format. So moment is force times perpendicular distance. We've got a force of 1.2 newtons caused by the ball, and the distance away from the pivot is then 0.2 metres. So then for point 5, where we substitute the answers in, we can see that the moment is the force, 1.2, times the distance, which is 0.2. And does this allow us to find the value to be calculated? In other words, do we need to rearrange? Well, no, because we've got the moment equals in this format, so we can then solve the answer. So using a calculator, 1.2 times 0.2 is 0.24, and the moment, the unit, because force is in newtons, distance is in metres, the unit for moment is Newton metres. So question 1 here is very similar to the previous one. Apart from this time, we've got a 10 Newton ball and we've got a distance of 0.4 metres. So again, the values, we've got the force, which is then 10 newtons. We've got the distance, which is 0.4 metres. And we said the equation was moment equals force multiplied by perpendicular distance from the pivot. So we can now put our numbers in. So number 5, substitute them in. So moment, rather than writing F, we can write 10 because that's the force, and then 0.4 for the distance. And previously, we didn't need to rearrange, and it's the same again here because it's moment equals. So moment equals 10 times 0.4. So we can then write down in the solve box 10 times 0.4, which is then 4, and then the unit, newtons times metres, so Newton metres. So question 2, similar again to question 1, in that we've got a ball with a pivot, but this time obviously 12 newtons, and the distance away is 0.5 metres. So as usual, we can write down the values. So the force is then 12 newtons, the distance is half a metre, 0.5 metres, and then the equation is moment equals force times perpendicular distance from the pivot. So we can then substitute the numbers in. So what I mean by that is put the numbers in rather than F. So F equals 12 and D equals 0.5. So 12 times 0.5, so that's then 6. And just as before, the unit is Newton metre. For question 3, slightly harder because it's not in newtons, it's in kilograms. So the equation needed to turn mass into weight or force is mass times gravitational field strength. So mass is 1.5 and roughly on Earth gravity is 10. So the force or the weight is 15 newtons. We've also got distance in centimetres, and of course that needs to be in metres, that's 0.35 metres divided by 100. So the values to write down, so the force is then 15 newtons, the distance is 0.35 metres. Our equation, moment equals force times perpendicular distance from the pivot. And if we substitute the numbers in, so moment equals 15 multiplied by 0.35, we can then use a calculator to find the answer, which is then 5.25 and the unit Newton metre. Question 4, similar to question 3, in that we have the mass and we need to find the force or weight. So the weight is the mass multiplied by the gravitational field strength on Earth. So that's 2.5, and roughly it's got a value of 10 on Earth. which then gives an answer of 25 newtons as the force. The distance needs to be in metres, and at the minute it's 25 centimetres, so we divide by 100 to turn it into metres, which is 0.25 metres. We can now put the values in. So the force, or the weight, we said was 25 newtons. The distance away from the pivot is now not 25 centimetres but 0.25 metres. Then we can put the equation, so moment equals force times perpendicular distance from the pivot, and then we can put the numbers in. So moment, and then rather than F we can write 25, rather than D 0.25, and then if we need to we can use a calculator to get to our answer, which then gives us an answer of 6.25 Newton meters. So question 5 is similar to what we've done with question 4, apart from there's a little bit more that we have to do afterwards, because we're not after the moment, we're after the force. So the force is 14 newtons, so we don't need to do any conversions here. However, the distance from the pivot is 0.35 metres, because we need to convert centimetres into metres, so we divide by 100. So we come up with the value of the force, which is 14 newtons. The distance is 0.35, and to find the moment caused, it's force times perpendicular distance away from the pivot. So we can put the numbers in to substitute to find the moment, and then the moment equals 14 multiplied by 0.35, and again we can use a calculator to get to the answer, which is then 4.9 Newton meters. However, that only gives us the moment caused by this force going down where it's that distance away. What we're looking for is the force caused on the bicep. So we know that moment is force times perpendicular distance, but now we know the moment, which is 4.9. We want to find the force, and we know that the distance away is 4 centimetres, so that's 0.04 metres. So to rearrange to find force equals 4.9 divided by 0.04, and again using a calculator, that gives a value for the force on the biceps as 122.5 newtons. So in other words, to hold a force of 14 newtons 35 centimetres away, we need a much bigger force on the biceps of 122.5, because it's a lot shorter distance away from the pivot or the elbow. Question 6 again is all about the force produced by the muscle. So we'll start like we did before. So moment equals force times perpendicular distance from the pivot. So the force caused by the ball is 16 newtons. The distance away we need to convert into metres, so 0.35 metres. The equation, moment equals force times perpendicular distance away from the pivot, so that's the distance here. So we need to put the numbers in. So the moment equals 16 multiplied by the distance 0.35, and using a calculator the answer gives us 5.6 Newton meters. But like the last question, this is the moment caused by the 16 Newton weight, whereas we need to find the force on the bicep with a different distance. So likewise, we do moment equals force times perpendicular distance, but this time the moment is 5.6. We're trying to find the force on the bicep, and the distance that the muscle is 0.04 centimetres away. So rearranging, force equals 5.6 divided by 0.04, which is 140 newtons. So the bicep needs to have 140 newtons pulling it up to balance the 16 Newton weight hanging down. And then for this final one, similar to question 6, apart from we've got a 2 kilogram mass. So weight, or the force, is mass times gravity, gravitational field strength. So that's 2 times, the value really is 9.8, but we can use 10 as an approximation. So that 2 kilogram mass is equivalent to a force of 20 newtons, its weight. So moment equals force times perpendicular distance from the pivot. So we know that the force is 20 newtons. The distance away from the pivot, the elbow joint, is 0.35 metres, because that's 35 centimetres converted into metres. So, like before, force times perpendicular distance, the force is 20, and then multiply that by 0.35, and that gives us a moment of 7 Newton metres. However, like the previous question, we want to find the force caused by that weight on the bicep. So if we know the moment equals 7, we can then put it back into the equation. So 7 equals, trying to find the force, our new distance is 0.04 metres, 4 centimetres converted into metres, divided by 100, and then we can rearrange to find the force. So 7 divided by 0.04, which gives us 175 newtons. So the bicep needs 175 newtons to balance out the 20 newtons caused by holding the ball away from the body.